Hello, everyone, and a very good morning to everyone that is joined in today. Lovely to have you all over here, and welcome to the AWS Solutions Architect Associate Level Certification Bootcamp. And this is the week one of our bootcamp, and we have two sessions that are scheduled for this weekend. Today's session on a Saturday from 10 to 11, we have the introduction to cloud and AWS. And we have our second session tomorrow that is a deep dive on S3, and that's in the afternoon around 2:30 to 3:30. So I would like to welcome our first speaker for today, who's Sanchit Jain. Sanchit, go ahead and take it away and tell everyone what you're going to um, give us today on Introduction to Cloud and AWS.
Sure. Thanks, Faisal. Thanks for that warm welcome. Good morning, everyone. Hope you are having a wonderful morning for this weekend. And thank you for taking out some precious time from your schedule to join our bootcamp. And as Faisal mentioned, we are very happy to kickstart our first week and first session, always a delight, which will be the introduction to cloud and AWS. Follow up, we'll have second session tomorrow, which will be focusing on the deep dive on S3, a very good service, which is we should look forward and understand in and out about it, right? So those are the two sessions what we have for this week for you guys to start with our solution architect certification bootcamp. Before I proceed with the next steps for today's slide, I would like to announce a couple of things. So after this session, we are going to share a kind of a link for a interaction platform where we can share all the materials, the videos which have been captured. So in case if you are not able to join the session, or there are something which you're not able to cover up in this session, we'll share the recording as well as the material, this presentation or any scripts on that platform. We'll request you to please RSVP or register with us. The link is given in the description of the session, as well as AWS also have reskill platform where there are study groups for all the associate certification. So if you want more hands-on, more peers to connect, collaborate with them, please do join with the reskill. The link for the reskill study group also will post in the description for this session. So please do join both of the links so you can have more people joining you, helping you and collaborating for the certification. With that, let's start with our first session. Today's agenda is going to be introduction to cloud computing, introduction to AWS, and the next steps around it, right? So starting with as my introduction, so my name is Sanchit Jain. I work as a lead architect at Quantify as well as an AP and AWS ambassador. You can reach out to me on different channels on LinkedIn, Twitter, or GitHub. Anything where you need my help in terms of certification, in terms of any community events. I'm almost active around across all the platform. Feel free to reach out to me. I'll try my best to get back to you or help you as far as possible. With that, let's start with the first topic around cloud computing, right? So generally, I think people, when they talk about cloud computing, there are different perspective of looking forward to it or understanding it, right? Generally speaking, I mean, if I talk about, people always think that cloud computing is very important, right? That is very true. With the new era or this way, I mean, I would say the post-COVID world, cloud has really picked up the market very well, and it's all over the place, right? You go across all the industries. Previously, if I talk about somewhere in 17, 18, there were specific industries which used to look forward. But if I talk about now, the current trend of the market across different, we talk about healthcare, financials, or manufacturing, any industries, cloud is really becoming the core and the central part of their organization, right? So it's very important for us to understand from basics what exactly is cloud computing, and then we jump on the AWS perspective, right? So in generally, if we talk about the cloud, right? So as you can see, that cloud is nothing but what you have is a kind of a place where you get an on-demand delivery of your compute, database, storage, right? Or application in couple of minutes, which generally takes like over a week or a month when you talk about any on-prem or a data physical data center kind of it, right? And as well as that's one thing, when it comes to even the pricing part of it, it's pay as you go, no kind of like an upfront cost and all, right? So it becomes very easy for the company or for anyone to get the resources, to spend the resources, play around with it as and when they want, based on the type of the use case and the based the kind of a flexibility around it, right? That makes cloud computing very adaptable and flexible across different kinds of stuff, right? From a kind of an education field to a complex enterprise kind of stuff. Whoever or whichever background you have, cloud is meant for everyone, which is was difficult when it comes to on-prem because you have to make an upfront cost and everything, right? So it's very simple. If I give you a layman definition of it, you have a laptop. In case of laptop, you have to purchase the laptop, you have to pay the payment for it, and those kinds of stuff, right? But if I tell you a simple definition, I can give you a laptop via internet, which you only pay what you're consuming, right? For sure that the second model is going to be cheaper because you're not paying like an upfront some thousands of INR to get your laptop. It's just what you pay and you use, right? So that's the general definition why cloud computing, or what exactly is cloud computing around it, right? Along with that, there are three perspectives of people generally look forward from cloud computing: is infrastructure as a service, platform as a service, or software as a service. Need not to worry about it. We'll have slides in upcoming slides where we deep dive or slice this in detail. What exactly are these three different models and why it is important for us to know about it, right? But for now, this is the introduction of cloud computing, on-demand delivery of compute, database, storage, and application connected via internet with pay-as-you-go kind of a model. Moving towards the next is around what is overall the cloud computing, right? If I talk about you in a nutshell, the cloud computing, what we have studied, there was a more of a theoretical definition. But now if we look in detail, so you'll see this is the exact cloud computing. Now there are two kinds of deployment models, service model, and there are different offerings, what you can see around it, right? So if we first go quickly around the offerings, disaster mitigation, broad network access, shared resource pooling, on-demand, self-service, optimal service utilization, rapid scaling, metered service, right? So these are the different features why cloud is very renowned, right? So if you talk about, it has the capability for disaster stuff, right? It provides network access, like from anywhere part of the world, you can access the resources which has been spent. It also provides a shared resource pooling, right? So if you're doing some more research and you want more, if a cost effective way of getting resources, so you can share your resources, you can pull the resources, you can have spot and those kinds of stuff, right? It's on demand, right? For example, let's say if I need a server, I can go on demand, play around with it. It's a very self-service kind of stuff. You don't need a very complete network team around it or an infrastructure team around it to spin up the resources for you and give it to you, right? You can do it on demand with a self-service mode. Optimal server utilization is, you can easily scale up, you can spin up the server what you want, right? Very simple of it. Let's say you need X core of your RAM. Tomorrow, if let's say you want to need Y core of RAM, which can be higher or lesser, you can easily switch that option without hardware configuration and those kinds of stuff, which you generally do it in our desktops and laptop, right? You upgrade your memory, or your upgrade your RAM or storage. You have to go to the local vendor, get the change and all. In cloud, that gets like, it's a few click where you can easily upscale or you can downscale part of it. So that provides more optimal part of it. Metered service, which is a very important thing. We generally keep hearing about pay as you go, as it was in the previous slide also. That's possible because it's a constant meter per second. Those kinds of billing is there to ensure that you only pay what you are using, and you, as per your scales increase or decrease, your commercial or the entire cost or licensing subscription get changed accordingly. And the scaling, which we all know that cloud is the, if we talk about the second name of cloud is elastic scaling. It scales as per your need, which maybe can be upscaling or downscaling part of it. So those are the different benefits or features, I would say, of cloud computing. And cloud deployment models can be three types, where you have public, hybrid, and private. Whereas if we talk about service models, infrastructure as a code, platform as a service, and software as a service. So this is like one perspective. If I talk about what can be cloud computing, if someone asks you, then this exactly is the thought process. There are a couple of benefits around it, features or benefits. There are two a deployment model is there, and then there is a service model. So this is in a one pick or one click, I would say this is about the cloud computing. If we go next around it and understand what exactly is the service model, right? So previous in the slide, we understood there is a service model is there, there's a deployment model. So now we'll focus around what exactly the cloud service model talks about. So cloud service model generally is of three types: infrastructure as a code, platform as infrastructure as a service, platform as a service, and a software as a service. So there are three different models are there. The left model is the on-site, which is the your physical data center or on-prem, where if you start from left to right, from an on-prem, you're responsible end to end, which includes getting the hardware, configuring the hardware, purchasing the hardware, or setting up the application security and everything, right? Patching, installing OS, maintaining it, operationalizing it, all you are responsible. So you will see all is in a blue color shade. Everything which is in blue color, you are responsible to manage. You, your team, or your company is responsible to manage it. In case of physical data center, completely it's on your host. So that's where you're responsible. As we move towards the cloud models, cloud service model, which is infrastructure as a service, the second column from left, where you will see there comes a red section at the bottom, followed up with the blue. Red section means the service provider, which includes AWS in this case. AWS will take care of this particular perspective, and you are responsible for handling the one which is in blue. So things like application, data, runtime, middleware, or OS, you are responsible for doing it, right? Simple example can be application, can be anything which you install, right from any web server to any application, custom application what you have built. That's as an application. Any data that get generated by that application can be log files or can be any transactional data. That's one. Runtime can be any environment, like Python is there, Java, those kinds of runtime around it. Again, the middleware part of it, any application, you have multi-tier applications, any sorts of middleware around it. And OS is, let's say you have Linux, Windows, patching of that OS, where you are responsible for infrastructure in a infrastructure as a service, you are responsible for it. Virtualization, configuring a hardware server, the storage, like mounting the volume to it, networking around, like plugging those servers into the different racks, connecting it to the network, LAN and all, which AWS takes care of, right? So when we talk about very simple example can be a service which Amazon provides is EC2 instance. Generally, when you launch, if you would have launched EC2 instance in the past or not, but EC2 instance, when you try to deploy it, right, we'll see in upcoming sessions itself or demo, you will see that you're only responsible to take care of this blue section, right? Physically, when it comes to actual virtual setting up like a server, physical server, connecting to network, mounting the hardware volumes or virtualization, those all taken care by AWS. You provide which kind of OS you want, what kind is of application or security patches on that OS. That is where you are responsible of it. Rest taken care by AWS. And as we move towards the third column from left, you will see platform as a service. So here you'll see the abstraction, I mean, the kind of responsibility of cloud vendor increases as we move towards the next column, where now you're only responsible for your application and data. Anything with respect to installing the OS or managing the patch and all, which cloud vendor takes care of it. And if you talk about software as a service, it's completely taken care of by the cloud vendor, like how it's been there. And general example, if I talk about on-site can be your physical data center, anything. Infrastructure as a service, the best example here will be Amazon EC2. Platform as a service, you can talk about something like Amazon, the Elastic Beanstalk. And software as a service, you can talk about any sorts of APIs. Like there are various APIs are provided by AWS, like Textract is there, Comprehend. Those are AI/ML services. Those can be like you just fire an API. You don't have to worry about any sorts of how things have been configured, how that service is configured. You have to fire a REST API and you get the response. So these are the different examples of it. As we proceed in our sessions in upcoming weeks, we'll zoom in each exactly service around this different section of it. But for now, just remember, cloud service model has three types of it: infrastructure as a service, platform as a service, and software as a service. Moving towards the next, which was on the left-hand side in the slide back, which was the cloud deployment model. So there are four types of offerings are there: public cloud, hybrid cloud, private cloud, and community cloud. We don't need to zoom this in detail from a certification perspective, but from your knowledge, it is very important that you understand. AWS, if we talk about, the other clouds we talk about, mostly are public clouds where you collaborate and you have your own specific section on it. That's a public cloud. Public cloud is very recommended way to do, because that shares the responsibility with yourself, right? You're not fully responsible for it. There's a shared responsibility, collaboration with the cloud vendor and yourself. And that way you can reach the market faster and get the outcome what you're looking in a faster pace. That's a public cloud. Hybrid cloud generally is between your public cloud and the private cloud, right? Generally, people do have public cloud for their any extensive public facing application. For any internal application, right? If you talk about for the internal application for their employees, they host in a private cloud, which is secured or data perspective, they do it, right? So that's a mix of between public and private. Private is something very specifically deployed for yourself, your company, where it's not you're responsible for maintaining the actual stuff, but it's specific deployed for your company. Whereas community cloud can be like a Heroku or something where it's collaborated multi-tenant, right? And used by different organizations and other stuff. So just to remember, there are 4 deployment models are there: public, private, hybrid, and community cloud, right? This is just for knowledge. This is nothing from a certification perspective, I would say. Moving towards the next, right? So as we studied in the slide back around the different types of cloud computing, right? Infrastructure as a service, platform as a service, and software as a service. So we understood in that slide pretty well that, okay, how exactly as you moved from left to right, from infrastructure as a service, platform as a service, and software as a service, how things changes, how much responsibility the cloud vendor takes care of it, and how much the customer is responsible for it, right? Again, so if you talk about the infrastructure as a service, you can see the example. We have studied this text very well in that particular block diagram. But if I talk about the example perspective, you can think about infrastructure services, Amazon EC2 instance, as I mentioned, EBS volume or VPC, right? If you talk about platform as a service, it can be like a Lambda, RDS, Elastic Beanstalk. Software as a service, Trusted Advisor, Shell, Chime. So these are the 8 different AWS services. You don't have to worry about what are the services, what are the use cases, because this all services will cover up week by week in our different sessions. But for your knowledge perspective, like how services get split across different kinds of stuff, that's more important, right? And again, the idea here to have infrastructure as a service, platform as a service, and software as a service is to ensure that customer gets whatever they require based on the kind of application, the kind of maturity they are into it. So it helps them to focus more on their business application or business requirement rather than worrying about the infrastructure or the platform that's required to run into it, right? So for example, if it is a kind of a very new startup, they don't even know about the cloud, they have very limited technical folks to handle, right? They can always choose like software as a service where they can focus on their business application rather than worrying about the maintenance, the operational, the patching, and all other stuff, right? So as well as if you, let's say you talk about, you have some small team of DevOps or small team of cloud engineers, not very scaled out, but still you want to focus on business, then you can go platform as a service where you get some more control to customize the stuff, right? You can just have some more, let's say, port level changes or some more customize in the way how data gets stored or data get handled. That can be offered by a platform as a service. Let's say you need more customization, more control over it, and you have a team to take care of it, then you can go to the infrastructure as a service. So that's how, based on the customer requirement and the maturity and the availability of their resources at their end, technical capability, they can select any of this offering here. Moving towards the next, right? That's always a question which I get in any of the session. Why it is very important for us to opt cloud computing? Why cannot we rely on-premise? Or what's the difference you generally get between on-prem versus cloud computing? So this is a general table I've come up where exactly what to understand how cloud computing differs from on-prem. We know a couple of things that, okay, here cloud computing can help. Generally, people, when you talk about cloud computing, simple definition is I can access it from anywhere. That's completely right. But there are other features and functionalities are there, which is important to know that why you should move towards cloud computing and how it can help organization to rapidly move or transform their requirement, right? So first, starting from the important feature from the top, which is around the security. So if we talk about the on-premise, you, your organization, or your team, infrastructure team, is fully responsible for it. Whether it's including, let's say, firewall rules, whether it's setting up any network control device, your organization is fully responsible to not only set that up, purchase that, or configure that, as well as maintain it. You're responsible end to end for it, right? So there is lots of responsibilities around it. Secondly, if we talk about the cloud based, even though it's been everywhere talk about that it's a service provider responsibilities there, but do ensure that it's not just the service provider responsibility. Like it's not just AWS, it's a shared collaboration between AWS, right? So if you talk about any services where you are responsible along with AWS to implement the security, AWS provides different features and functionalities, and what proportion, what amount you have to configure that, there you're responsible for it. So it's a shared collaboration, right? So your most of the work is being taken care by AWS. You have to configure it, maintain it, or monitor it in a right way. So that over reduce your burden when it comes to the security, when we have this comparison between on-prem and the cloud. Moving towards the second point, which is the customization. Customization is very difficult. Like if I talk about that simple example, right, where I have, let's say I required a server which needs me, let's say 4 GB of RAM and 100 GB of hard disk, right? In on-prem side, if I want to upgrade, make a change like from 4 GB to 8 GB or 4 GB to 2 GB, I have to literally take that hardware device, go to any local vendor, get a new hardware device and change it, right? It's not that easy. It's minimum is going to take few days. If we talk about the cloud base, it's very easy. You just have to go on a console, or if REST API, you have to just provide the right detail and you can do it in few minutes. So that's a big difference. It is very simple to customize it and update the resource as and when required versus in the on-prem side of it. Updates. In case of updates, organization has a choice, right? So for an example, couple of organizations still uses the older version of any operating system because they are comfortable that the application dependencies there. Like specifically, I talk about the banking, right? You will see banking sector uses the operating system, which is a bit outdated according to us, but there is an application that runs which is tightly coupled to that. So they have a choice whether I need to upgrade it to the next level or not. In case of cloud-based, it's not that fully you don't have a choice. You do have a choice around it, but depends on what different cloud service you have, right? So we studied three different types: infrastructure as a service, platform as a service, and software as a service. Based on the type of model, service model you are into, it depends on do you have the control or not. If you talk about infrastructure like Amazon EC2, for sure you have the control whether you want to apply the patch or update or not. But if I talk about, let's say, platform as a service or software as a service, where cloud vendor is responsible for it. So that's the difference and update part of it. Next is the ownership. Ownership, I think we all know about it. We have studied enough points that you are responsible for end-to-end complete ownership around the server, the hardware, the data, the software, and everything. Where in the cloud, it's mostly again the type subjected to the type of the model. You are only responsible for the kind of the application or server or data, right? So again, the mapping back to that table where you have infrastructure as a service, platform as a service, and software as a service. Auditing perspective, it is very difficult. Now, this is a very important point, right? People generally think auditing is easy on premise compared to cloud. It's a subjective point, right? Which we can look forward. Auditing can be difficult, can be easier based on how exactly you have or what kind of application you have on premise, right? But if you don't have a proper practice setup of auditing it, then it becomes very difficult. I've seen a couple of organizations in my experience running on physical data center. They didn't have like a good capability there around it, and then wiring on top of it becomes very difficult in on-premise, right? In cloud, it becomes very easy, right? Very native, or the basic, I would say, fundamental is you just have CloudWatch. Any services, anything what you launch in AWS, behind the scene, it is integrated with the CloudWatch. So you start getting at least the basic level logs, which you need to customize it. You need to configure it in a right way, and you can get more sophisticated way of monitoring and logging. But bare minimum you start getting as you start logging around it, right? With help of CloudWatch and CloudTrail kind of stuff. So auditing is very simpler if we talk about the cloud. Connectivity. Most important point about it, it is very difficult when it comes to connectivity, right? Defining those networking topology, having that very cost effective or cost, I would say, broadband kind of stuff, right? You need GBPS kind of broadband if you need a more sophisticated kind of system, which is very difficult in on-prem. I mean, it's really very difficult. I cannot explain about it, right? Let's say for a simple example, you had some surge or network surge, your entire on-prem system will get down if you don't configure it in high availability, right? Because that's a backbone of your entire on-prem or your entire LAN. So that becomes a very crucial and key role around the connectivity part of it. Where in case of cloud, you don't have to worry about the connectivity. AWS takes care of it. You just need to have the connectivity at your end, which is the internet. So via browser, you can go, you can access the console, or you can fire REST API based on your use case. You can take care of it. You don't have to worry about having those network big topologies, different routers and connectivities and all those stuff. So it simplifies your overhead much more. Affordability, only big size organization can afford it, as I mentioned. Whereas in case of cloud, it's not just the organization. Cloud is even for a general guys, right? Even if you're into undergrads, you're into your schools, you're into your any research, you're into any organization, either startup to an enterprise. Cloud is meant for everyone around it, because the best part of cloud is accessibility from anywhere, pay as you go, and the shared responsibility makes it more adaptable across all the kinds of folks. So that's the big difference, I would say, between on-premise and the cloud computing part of it. Moving towards the next, so far we have understood like too many things about cloud computing, different offering models, the types of cloud computing, difference around it, right? Let me quickly summarize the 6 advantages from what we have learned so far. And you will see these points are almost we have covered in the previous slide. So there are 6 points around the 6 advantages, I would say, of cloud computing. Trade capital expense for variable expenses, right? So in case of, if I talk about on-premise, right? In case of on-premise, it is very variable. You don't know about it, right? For example, now you had like 6 server requirement. In 2 months, you need 4 more servers. So it becomes very difficult to keep a cap how the load is increasing versus what kind of requirement you need, right? Whereas in case of cloud computing, as I mentioned, it is easy to configure. So you can not only just monitor and track it, but you can even optimize it to ensure that variable proportion decreases over a period of time, and you can estimate the right stuff around it, right? Right numbers. Benefits from massive economic scale, right? There are many benefits around when you talk about the economic scale perspective, right? The same thing when you talk about the upfront cost kind of stuff versus what you can have, right? So that becomes very important. Like, for example, if I talk about a startup, like a startup which is just launched today, now they want to launch their first website. It becomes very difficult for them to focus on their business or what they want to do, right? So there it becomes very difficult that not just from a helping perspective, but even from massive economic scale, right? How you want to scale the things, how you want to take care of like scaling around it. So that becomes very important. Stop guessing your capacity. Now, in case of on-premise, you only rely based on the estimations. Estimations, what you gave, let's say 3 months ago or year ago, that okay, I may need 10 resources or I may need 12 resources. That may word generally doesn't work out very well because you don't know how exactly your application pick up, right? It may pick up beyond that, or it won't even pick up. So that stop guessing around it. Where in case of cloud, you can upscale or you can downscale with few single clicks. So in case if it is a boom, it picks up the market trend, you can easily scale that out. In case if you don't get that traction from the market, you can easily scale down. So that helps a cost saving around it. Fourth point is around the increased speed and agility. Now, so far what we have learned that you don't have to worry about the networking part of it. You don't have to worry about the entire configuration of the server. You only mostly, if you talk about any 3 model, infrastructure as a service, platform as a service, and software as a service. The prime motto is you purely focus on your business application. And when it comes to the actual operational part of it, cloud vendor will help you and collaborate with you. That gives you more speed and agility to purely focus on your business application and deliver that with a faster pace in the market. That's around it. The fifth point is stop spending money running, maintaining the data centers, right? It's not just about getting and procuring the hardware and configuring. You also have to maintain, monitor it over a period of time. So that maintenance cost, staff cost, operational cost also increases. In case of cloud, you just have to provide or configure the right monitoring and services and don't need like this kinds of heavy investment when it comes to maintenance and operational stuff. And again, there are different ways of like DevOps and those kinds of other practices, which we'll learn in upcoming sessions, where you can see how even you can try to automate or minimize that operational stuff also. Last, go global in minutes, right? As I mentioned about, let's say you have physical data center at, let's say, India region. Now, if you want to build a similar in US, UK, or across different globes, it is very expensive. You cannot do that, right? Let's talk about, let's say, cloud computing. That's the best part. You can easily scale your application as well as you can deploy that application geographically. You don't have to worry about, let's say, you have an application which you want to deploy in India, US, UK, or any rest of the part of the world. You just select that particular application, look around the different kinds of compliances, and you can take care and you can deploy in that region without really worrying about do you have that physical data center in that region or not, right? So that help you to go global in minutes and purely focus on your business needs and ask rather than worrying about what's the server size, what's the server investment, licensing, and those kinds of stuff. That's at the big six advantage of cloud computing. And next, we'll move towards the introduction to AWS. I think whatever we have learned so far in the previous slide was around the cloud computing, right? That same knowledge what we have procured or we acquired just now will help us here to map like how exactly AWS work in a very zoom in view. So AWS is a public cloud. So we learned like public, private, community, and hybrid, right? So AWS is a public cloud offering, right? Which provides you compute, database, storage, connected via internet as a pay as you go model. It provides you the same thing, right? Fast, you just focus lower IT cost, scale your application globally in a very faster spend, in a shortest time spend, right? And as well as it also provides you the global infrastructure, not just okay, it will only offer you in India or it will only offer in US. You are in any part of the world, it provides you the capability to go globally, and it has the region rich across dozens of different data centers spread across different regions, right? Don't worry about it. What is data center? What is regions? Availability zone? We'll cover up in upcoming slides around it. But in a high level, this looks like the global infrastructure part of it, where there are different regions around it. Then there are each regions is connected, right? So the only key point where we have to focus here is that there are different regions. In short, if I summarize it, regions is nothing but a geographical location. Like India, US, in US, there are multiple regions are there, but just from now, just think of it, India is one of them, US is one of them, UK is one of them. There are such different regions. They are all connected with a high speed network bandwidth. This entire provisioning of this region, connecting them, this all geographical regions, connecting them with high-speed network, everything is taken care by AWS. You just have to deploy your application in the right space, which means right region, in right security. That's it. You don't have to worry about any sorts of hardware or any sorts of connecting of this networking cables and all those stuff, right? That's the first significant difference what we can see when we talk about the on-prem versus the cloud AWS precisely. So that's about it. Next, we'll go around and we'll understand what exactly in the detail is like regions, if we talk about data centers, we talk about, or availability zone. These are the very crucial. And I would say the first thing, the alphabets of AWS. If you get this very clear, you can easily learn the remaining services on top of this thing. So if I increase or zoom in the footprint of global infrastructure of AWS, right? There are 84 availability zone, 26 geographical regions, and 20 more availability zone and 8 regions are there, right? This is for your knowledge that how exactly AWS is scaling massively to ensure that they globally cover all the different regions, not just globally cover the regions, as well as provide more different redundant regions in a same country, right? So for an example, if I talk about India, currently India already have a region in Mumbai. They're also planning next year, 2022 or early 2023, to have one more region in Hyderabad, right? To ensure that not only just they have the coverage in India, but as well as they can provide some more better functionality like disaster recovery and all those stuff. So you can have both two regions in same country itself, right? Similarly, if I talk about US already have like 4 regions, North Virginia, Ohio, Oregon, and California. So to ensure that whenever the US folks or any company in US, they want to ensure that they have their application deployed, data stored within US itself, they have multiple options to look forward within that country itself, right? That's the entire thing AWS looks forward, not only just globally connect across different regions, but have more redundant region to ensure if there is any compliance need, they also match that compliance need part of it, right? And then outside 26 regions and 8 more coming soon, there are 84 availability zones are there within the regions, which you'll understand how exactly regions and availability zone differs. But just remember, there are 84 availability zones are there. and 24 more coming out of it. And it's become, I'll tell you honestly, this numbers changes because as AWS increases, as new regions come into it, this availability zones number also increases now. This is just for your perspective, how exactly the global footprint of AWS is. And there are then different, I would say, point of presence, which is nothing but like a caching locations are there. Then there are data centers around it, local zones. So those are the different other, I would say, sub networking or sub more point of presence out there. This is a more important thing, I would say, in global footprint outside understanding how massive infrastructure AWS holds is the three different things: region, availability zone, and edge location, right? So if you look into this diagram on the right side, you will see a region. Now, this is like a EU West 1 region. Within that region, you will see a different availability zone. So region is nothing but a kind of a single geographical location, right? Geographical region. So if we talk about the same example of India, Mumbai is a region. Now within Mumbai, you can deploy, you have different availability zones, different data centers, right? Data centers are like geographically segregated within that same region. So you can think of this EU as one region. Within that region, you have different availability zones, right? Different data centers around it. So availability zone is more to ensure, let's say for an example, there is some sort of natural calamity, some disaster is there, some outage is there. To ensure that your application doesn't suffer, you can have multi-availability zone. You can deploy an availability zone 1A, 1B, 1C within that region. So you can have different redundancy around it. And each availability zone is made up of one or two data centers around it. So let's say if I talk about physical, these are actual physical data center maintained and hosted by AWS. So each availability zone has one or two different data center. Each region has bare minimum 2 to 3 different availability zones. And again, that is minimum, they are made up of 2 or more around it, right? If I talk about North Virginia, I think there are somewhere around 5 to 6 availability zones are there. So as per the popularity, as per how people are growing, that region is going, the availability center, availability zone also increases to ensure there is a proper redundancy is provided, and there is minimum of outage and all. There are other perspective also how we can achieve disaster recovery and everything, which we can focus. But for now, very simple of it. There is a big box, which is the region. Then there are small box, sub network, which is availability zone. And in that sub network, there are different small 2 or more data centers are there. So region, availability zone, then there is a data center, right? So now if you go and learn the theoretical part of it, you will understand very easily what I'm trying to convey. So region is based off specific geographical location. Think of Mumbai in your head, like in India, is a specific geographical location made up of 2 or more availability zone, right? So you can think of like Mumbai is one big region around it in India. Then there are sub availability zones, which is geographically segregated. It's not that in Mumbai itself, they have 2 availability zone. It will be having some distance, some geographical distance. So if let's say there is earthquake or floods or anything in, let's say, one specific availability zone, the second availability zone can continue serving the traffic. So both are geographically distant, I would say. So that's availability zone offers a specific subsets of services, right, around it. So in case of regions, if we talk about, let's say it might be possible, most of it, I mean, the services are available over a period of time, but it might be possible that there are very new services which get launched in one specific region may not have in another region, right? So that becomes, sometimes you have to be very sure that based on the kind of services you need, you have to choose a region. So that's about the region part of it. If I talk about the availability zone, which is the second key thing, is it's made up of 1 or 2 different data centers are there. So as I mentioned about, within the region, you have 2 or more availability zone, and each availability zone is made up of 1 or more data centers, which is the actual physical data center from where you can spin up the resources and all. As well as it's already ensured that the data center within the availability zone is connected with low latency. So you launch, let's say, 1A or 1B or 1C, right? Within that same availability zone 1A, there are, let's say, if we talk about this 3 data center, they have very high speed network, so it's a lower latency. So any data center you deploy around the resources, the experience is going to be the same part of it. And the last is the edge location. Edge location is for your caching, right? You can think about like your caching or any other stuff. So in case, let's say you have your customer specifically using in this India region, right? So if you talk about Amazon.in, very simple example, most of the people uses Amazon.in. So you want to ensure, right, the kind of response, the kind of latency which you have in Amazon.in should be as less as possible. That is almost achieved with help of caching. The entire solution, the traffic get cached in a near point of presence, and from there it get served to you to ensure that you have a proper response time of the website. So that has been done via Amazon CloudFront and those kinds of services. There you need an edge location around it. So edge location is outside to the availability zones and all, but do remember edge location is very important when we talk about the caching and those kinds of stuff. So this is the AWS global infrastructure map. You have a region, you have different availability zones, and each availability zone, you have different data centers. Moving towards the next, right, when an important point, how to choose a region. I think somewhere I already tried to cover up in the last slide, but let's say how to choose a region. Like, am I working in India or I am based out of India and specifically in Mumbai? Then does that mean I should go with the AWS region of Mumbai or AP South one, or what exactly I have to do? So there are four perspectives which should always be looked forward. One is a data governance, like a legal requirement. Second is proximity to the customer. Third is service availability within that region. And fourth is a cost. I would say first 3 points are very important. Cost is very significant difference. It's almost like I would say a couple of cents, but 3 points, the first 3 points are very important, which you need to understand. Let's say, many people do work for US companies, right? Like you're working here, but you're building an application that will be used by the client based out of US. Since you are based out of India, that doesn't mean you will use AP South, right? There are certain compliance requirements there. Like if I talk about a couple of industries like banking, financial, healthcare, they have different regulatory to protect their data. They have different laws, compliances to ensure the data that is generated from that particular industry or particular facility doesn't go out of it, right? So similarly, if I talk about US, they also have such kinds of compliances. So let's say if you're working for any US client which you will be using the application, you have to ensure the application which you're building has any sorts of data governance, regulatory, or legal requirement. If yes, then for sure you should deploy in US region itself, right? To avoid any sorts of security or data breach. That's one. Two, proximity to the customer, right? It's the same thing. You try to access a kind of a server which is way ahead, located, saturated in any part of the world. There is some latency that you will face, right? So always ensure that wherever your customers are situated geographically, choose a region in that area so they get a better experience around it. Third, service availability. Let's say, for example, you need very specific services and that service is not available in your region. So then you have to choose the region which has that service and which is close to your customer around it, right? So I would say these are the three important things. And fourth, there's a small thing is around the pricing part of it, right? Pricing in sense of like, okay, there are a couple of differences, small differences you will see in terms of the pricing part of it. But as I mentioned, as I call out, first 3 points are very important when it comes to choosing a region of that stuff. Next, an important way, right? How exactly you should interact with AWS. Like what are the different mediums are available, right? So there's a beautiful slide or an image graphic provided by AWS. There are 3 ways you can interact with AWS. For sure, AWS console, which is like a website, what we call about, or a kind of a graphical user interface. The console, which we'll see in upcoming sessions when we are doing the demos and all. That's one way to look forward. Second, if you are a technical developer or a DevOps or a cloud engineer or any technical resource, command line, you can fire, AWS has its own CLI command line interface, a utility which you can set up in your laptop and you can access from command line. Third is a software development toolkit. If you are pretty good experience with, let's say, Python, Java, Ruby, Golang, you can use those kinds of .NET. You can use those languages to interact, right? But one of the important thing is any medium which you use, whether you talk about AWS console, whether you talk about CLI, whether you talk about SDK, underneath behind the scene, AWS follows the principle of microservices. So whenever or any action which you do, there is a bunch of different microservices that get executed on behalf of you based on your action. What does that mean, right? For very simple example, you log into AWS console, right? It's a GUI. In that login also, there are APIs in the backend which AWS fires to validate your credentials, to provide you a role, the permissions in short. So you can see the console around it, and then based on your permission, you can play around the services, right? Or anything. Another example can be listing the Amazon S3 buckets, right? We think, okay, it's very easy. I click on S3 icon, and then I get a list of all the buckets, right? Which are there across different globally. But behind the scene, those all results are served by multiple microservices that get fired around it. So whichever medium you use out of these three, there are a bunch of microservices that get executed to serve the result back. Now, if you have GUI, the result will be, I mean, you'll get the response, and then there will be a graphical layout or interaction on which it will be rendered. If it is command line, then it can be rendered on JSON or however you have configured. If it is more in a Python, again, however you have provided in a JSON or a dictionary or any way, you get that response back around it. But underneath, there are a bunch of microservices which get executed when any action which you perform by any of this medium. But there are three other mediums. When you will be doing the demo, we'll ensure that we cover up three of this medium across different demos, so we get awareness about how things work across three of it and how much it is easy to play around with it. Next, the important part is the pricing part of it, right? So it is always important to understand that the services which you use, how exactly the pricing of that works, right? The very thumb rule of AWS is pay as you go pricing model, right? There are, I mean, whatever you use, you pay as you go. Like for example, let's say today you spin up one service, so you only pay for that service, right? Tomorrow you, let's say, spin up like thousands of other services, then you pay for those thousand. It's not any upfront cost that, okay, no, you're going to spin up thousand services in future, so I'm going to charge for that thousand. It starts from what you are consuming, and as you scale, then they will be charged as that kind of stuff, right? So there are three different side of it: compute, storage, data transfer. So high levelly, any compute what you launch, right? Whether it can be Amazon EC2 or containers or serverless Lambda, anything, whatever you consume based on the configuration, that get charged. Second is the storage, right? Whatever the data you store, let's say in such a volume instance of S3, that is a storage that gets charged per GB wise. Third is the data transfer. There is no inbound charge. So data transfer is of two types: inbound, outbound. Inbound is something what is entering in AWS. Outbound is what is leaving AWS, right? So AWS doesn't charge you for inbound it, but for outbound, the total data transfer across different services get aggregated, and then you're charged for the outbound transfer, which is again per gigabyte level, right? So these are the three high level things you'll say: compute, storage, and data transfer. Based on the different service what you have launched, which falls across this category, you get charged around it. But on the right hand side, if you see, there are different ways where you can also try to reduce or optimize your cost and get some more savings around it. Like for sure, pay for what you use. That's one of the things. Second, pay less when you reserve, right? There are different options are available by AWS to reduce your cost, right? Because end of the day, we say we are using AWS around it, but AWS also have to invest lots of money in their physical data center, right? To give you that capability. So if you make some reservation, if you tell AWS, I'm going to use this server for a year, I'm going to use this server for X number of hours, or I'm going to use this specific category of server, Amazon gives you those different discounts, which they get at their end. They try to give that benefits to their customers, right? So those all will get into it when we are going into EC2 section. But do remember, if you're using or giving some sort of a commitment to AWS, it also helps you to get some sort of a saving around it. The third point is pay less when you use more and grow as more. Again, that same kind of offering. If you tell AWS uphand that, okay, I'm going to use XYZ, I'm going to use this particular enterprise use case around it, there are different ways, different discount programs where AWS can enroll you, and you give them a commit can that over this period, I'm going to spend this much, so AWS can internally handle around it. So give you more cost benefit around. So these are the different pay-as-you-go model also. You can, I mean, that's a thumb rule around it. You can try to save more cost from that also. And in terms of the high pricing perspective, compute, storage, and data transfer. Moving towards now, the important part. We understood the introduction of AWS, the global footprint, how pricing works around it, right? Now let's go to the core of it, what AWS offers to us as a different services. So this is high level services map, right? So I don't know, I won't go like a very zoom in view of each services, but let me walk you through category wise what are the different AWS services have been provided in this session. So application, I mean, different AWS services have been categorized into different categories. If we talk about like high level, starting on the first column, you have infrastructure, then you have foundation services, platform services, and applications, right? If I talk about infrastructure, we somewhere have learned through in the previous slide regions, availability zones, edge locations, and all, right? Foundation is more like around infrastructure as a service. We talk about Amazon EC2 instance, VPC, volume. Those become the foundation, right? The core of any services where you need, right? Then becomes a platform as a services, which includes your databases, your analytics. Like databases can be your SQL Server, relational database. Analytics can be big data platforms, your Spark or ETL, those kinds of use case. Warehouse like Redshift. Application is more like step function, airflow, or those kinds of more application requirement. Deployment is more like a DevOps kind of services. And the last, what you have is a mobile services, right? As people more have gone to device friendly kind of approach, you have any mobile application which you want to build or you want to test around it or want to send notification, those falls into mobile services, right? And at the last, the application. Let's say you want to have virtual desktop, right? Or you want to collaborate like Word, Doc, and those kinds of stuff. You want to collaborate with those kinds of stuff. You can have those collaboration and sharing like Chime and all those things also you have under application around it. So this becomes the four categories, I would say: infrastructure, foundation services, platform services, and application services. In next slide, as I mentioned in the kickoff section also, there are somewhere around 30 to 35 different services what we'll be covering around. And as we go around those services, we'll try to cover each of this pillar, right from infrastructure, foundation services, platform services, and application services. Just if you want to quickly scan around each of these different sections, right? So in compute, Amazon EC2 is there, Elastic Beanstalk is there, Lambda, Fargate, those kinds falls into the compute. Storage, S3. If I talk about networking, you have VPC and Route 53. These are the different services. You don't have to worry about what are these different services. Just for your understanding, high levelly, there is a set or category of services, which is like compute, storage, networking, database. And under each of that category, you have different services provided by AWS to ensure based on your business requirement, your application requirement, you get different kinds of offering, which try to reduce or minimize the operational stuff and gives you more better cost effective way of doing the things, right? So there are different kinds of categories and services provided, which we just learned in the previous high level view around it. And couple of services from here, we will deep dive in detail from introduction to hands-on demo to benefits feature, like how they work behind the scene and where exactly they are useful in this real world about it. But still, if you just want to refresh your if you already have explored AWS in the past, or if you already have any certifications of AWS, you just want to quickly refresh your memory, you can go through this table and refresh it. But for the guys who are pretty new to the AWS and this is your first session around it, don't panic. We'll go through all of these services in different upcoming sessions. At the last, the most important thing, generally AWS shared responsibilities come later, but I want to cover up in the first session to ensure that it's not just AWS responsibility for handling or maintaining or security, right? It's a collaboration. I always love word collaboration. It's a collaboration between the customer, me, you, or anyone who's using AWS, the customer or who's responsible, and AWS. It's a collaboration, right? So the orange section, if we talk about, AWS takes care of it, like things like physically securing the server. So someone don't go ahead in the data center, store the volume, store the hardware, or do any sorts of cyber attack on their actual networking, which is there, right? Those all things are responsibility of AWS. But if I talk about, let's say, applying the security patch on EC2 instance, ensuring your data stored in S3 bucket is properly secured, it's not publicly accessible. These are the controls where customer is responsible, right? For example, generally I keep hearing about it. People do have credentials and they take like access key, secret key, username, password, and put into any public repository. Now, if you end up doing that kind of stuff and then you get compromised, your security get compromised, that AWS is not responsible for it. You guys are responsible because you left your credentials into public store, and that's how it's been there, right? So this is very important. For sure, we'll have one more details session about this, but for now, it is very important that as you start going and doing more hands-on, please ensure that you use your credentials, you use your other details like your SSH keys, your credentials, the server which you deploy are not publicly available. They are meant for your specific use case, whether it's your business use case or for your own research. So it should be only accessible or only used by you guys or your team or your company, not the entire world. So that you have to take care of it. Whereas the actual securing around the hardware or the software kind of stuff, AWS takes care of it. So do ensure that kind of responsibilities around it. So this is again a zoom in view, services wise, how exactly what all the orange section AWS takes care of it, whereas the blue section customers takes care of it, right? This is the same concept what we have even learned. The first left side is the more of infrastructure as a service. The second is more around the platform as a service, and third is the software as a service. As you go forward, you will see the proportion of blue segment get decreased and orange increase, where AWS is responsible for handling all those kinds of stuff, and you are responsible for whatever the requirement is, right? If I talk about the extreme right, you're responsible for ensuring your data, as I was talking about the S3 example, right? If you store any sensitive file, let's say your credit card pin into S3 bucket, and you make it public, and then if you say my data got compromised, then it's your responsibility because you should not do that. It's your data, you have to securely save it. AWS provides you a kind of a secured vault where you can save it. But if you left that vault open, then it's your responsibility. So that's how things work in a shared responsibility model, from infrastructure as a service to platform as a service and software. You will see the customer responsibility is getting decreased, but overall, you are responsible along with AWS. You will see never a phase or kind of a block where AWS is completely responsible. At least you are responsible even in software as a service to secure your data. So this is a more important and crucial thing, that security is a shared responsibility between AWS and the customer, not just the AWS. And the last thing about the free tier, right? So I want all of you guys, if you already have an AWS account of your company or education account, or if you don't have it, then please launch an account of AWS, right? If you need, I can also publish a document in a repository along with this presentation, which will help you guidance how you should spin up a free account. In case of when you're launching any AWS account, it's enterprise, it's education, research, the first year is free, where you can get like free tier kind of stuff. There are a couple of things, options are available, like free trials are there. 12 months, as I mentioned, 1 year is free. And there are a couple of services which are always free, monthly basis quota are there, right? But there are few services, the specific services what we will need for the demo for this upcoming sessions are almost fall into free tier, and will ensure that it's in free tier. But again, you have to be responsible that you stop the services after the demo is done, you destroy them, you don't keep them running. If you follow the proper precautions, then you can easily will get $0 charge for the account which is there, right? Personally, even what demo I do it, I use my account, I'm almost not being charged for almost like 2 to 3 months, by ensuring all the best practices, that once I'm done with my demo, I clean up, I destroy the services which are not required, and if I need it, I put it in the stop mode so I can use it later on. So if you ensure those all small things, small best practices of optimal use of resources, you can easily finish up this entire bootcamp in a free tier mode. So that's about it. And if you see on the right hand side, there are few services are there which is at free cost. We'll understand in upcoming sessions why they are at free cost, why AWS is not charging for them, or what get charged on specific, I mean, what exactly get charged when you are launching these services. All those detail will get in upcoming slides. But this is very important to ensure that everyone, all the participants of this bootcamp do have access to the AWS. Whether you have in your company, check with your company if they can give you, that's good. If you already have it, that's wonderful. And if you don't have it, please go and launch, because you will have a 1 year free tier that will help you to do hands-on and get your certification. At the last, I want to call out the appreciation for the guys who are the brain, who are working in and out to organize this boot camp. So there are Abhishek Wagh, Faisal, Parth, Prithvi, Nipun, Saurabh. So there are a couple of volunteers, organizers who are working in and out to ensure that we have successful bootcamp, to set up all kinds of interaction platform for you, to ensure that you have a wonderful learning here. So this is the core group and organization, and there are supports what we are getting from different AWS user group, a best community platform where you just have to help them, you have to reach out to them, and they are very open to support you and motivate you. So there are different AWS user groups which are supporting us: user group Dehradun, user group Hyderabad, Indore, Nasik, Rajkot, Ranchi, and many more. So when you have talking about any sorts of communication, any sorts of ideas, user groups are the best place. So uh, if you're not part of any of the user groups, I would request highly go and check out your nearby user groups. They're the best way, a community platform to not only approach for study groups for certification, but even to learn about the new trends which is there in the market, what's new happening in AWS, how you should look forward to it outside your certification part of it, right? Or what should be the next after your certification. So do reach out to your nearby user group. And if you don't have it, please reach out to any of this organizer and volunteers will connect you in any of your nearby user group. So that's about from today's session. I'll try to again recall. Please RSVP the link which is given in the description of this video. We will send out a kind of a link to onboard you for the communication platform, to share all the materials, updates for the next sessions and presentations, as well as Amazon AWS also provides a reskill platform. So there are specific study groups which are already there. To have more collaboration, more interaction, please reach out or join that study group so you have a wonderful experience and a better learning throughout this journey. Thank you so much for joining the session. I know it's very difficult on weekend morning to be there at 10 a.m. for the session, but I really appreciate all you guys, your energy for reaching out and joining the session. Hope we see continue that participation in upcoming sessions also. Thank you.
Thank you, Sanchit, for that wonderful session. Um, so I hope everyone actually got a pretty fair idea on what is the cloud and the basics of AWS in terms of all of the regions, the free tiers that you get, and kind of the common services that are offered. So I just want to remind everyone we are just getting started. So this was just our first session. So we have many more sessions lined up for you, and the next one is tomorrow afternoon, starting at 2:30, and that session is going to be a deep dive on S3. So I hope everyone will continue to join into our sessions. We do have not just the sessions, but there are other things that are also coming in that will help you with the certification preparation. And like Sanchit has already mentioned, please do use the link that is posted both in the chat as well as the description, so that we can give you access to the chat groups, which will help you kind of ask questions if you need any help with any questions that you have about any of the sessions that we're doing here. Additionally, there is also the AWS Reskill program, and they do have a study group that is running for each of the certification programs that are there. So that link is also pasted in the description. So please have a look at that if you find that interesting. So once again, Sanchit, thank you, and thank you to everyone else who joined in. And we will see you tomorrow at 2:30 for deep dive on S3. Thank you, everyone.
Thank you, everyone.